6/9 now. Didn't make any mistakes there, did we? Hey folks, welcome. Welcome. It's summer school time, Tea and Learn Mathline, all those great things. I'm Ernie Roberts, and I'm your host for this afternoon session. And you know, it is summertime. We have a lot of fun here, and we're glad you've tuned in to watch us this afternoon. Again, Ernie Roberts, I'm your host, and we're going to be doing some great things helping you get ready for the next school year. We've been reviewing, we've been rehashing, we've been remediating. We are doing the basic fundamentals this summer, trying to get you ready to go back to school and be ahead of the game, or at least where you're supposed to be come fall, come August actually, when we do that, right? So sit back, relax. We're going to do some math. You need to get some pencil, some paper, and probably no calculator needs today, but we are going to do some good, fun stuff. It's not a call-in day, so just like I said, sit back, relax, and hey, let's do some math. What's our topic for today, guys? What do we got? It is summer school, and we are breaking away with fractions. Breaking away means, well, we came together when we added, so breaking away sounds like we're going to be subtracting. And we're going to be using the mixed fractions a lot today. Now, we've done subtraction of fractions before on the show. We've done mixed fractions probably before on the show, but today we want to just really focus and hone in a little bit on that. But you know what? In order to subtract, I mentioned it earlier, we've got to come together with adding. So let's take a look at one addition problem and refresh our memory on what we need to do there. So let's see what we got going here. First problem. There we are. It says add these fractions, reduce to lowest terms. We're always looking for lowest terms. And remember, to add fractions, and by the way, the reason I'm going with one problem of adding fractions for us, we subtract, we have to have common denominators also. And that's what we're going to do here. We're going to go back and refresh your memory. So go ahead and write this one down. It's pretty straightforward. It's 1/2 plus 1/3 plus 1/4. And I'm hoping you have some of these things going in your head before too long, but for right now, I'm just going to spread it out here a little bit because I'm wanting to point out, how do we change? How do we find a common denominator? Now, if you're like some of my students, you go like, oh, what does add 2, 3, and 4, and you get 9? Well, it doesn't work that way. Not anywhere close. So we have to look at a number that, not that these add up to, but that these will all divide into evenly. So perhaps a multiplication situation will get us started. Certainly it would be a good way to go. Let's try 3 times 4. The two numbers are close together. They are actually right next to each other. So you know you have to multiply those two numbers together to have something that both will go into. Well, that number's 12. Now you ask the question. We got 3 times 4. What will happen if we divide 2 into 12 evenly? Well, it's even, right? It goes even. It goes 6 times. So that's good news, because that tells us, tells you, me, and everybody, we need a 12 down here. We need a 12. Put a 12 right down there, and we'll put it all together in just a second. Now, what do we do? Well, we multiply this 2 by 6, all right, to get to 12. If we multiply in the denominator by 6, we got to do it to that numerator. It's going to give us 6/12. 6/12, all right? How about it? This little guy over here, we multiply by 4, and got to do the numerator by 4. So I've got 4 over 12, 4 over 12. Last but not least, I've got a 4 down here. Yeah, we're going to multiply it by 3. Remember we did 3 times 4 and 4 times 3 to get to those 12s? That's how we get a common denominator. And it so happened, like I said, that 2 would slide right into it also, so life is good. 12 all the way across. What's left? Got to multiply by 3, and we put a 3 up there. Now, I'm going to tell you, some of you probably can leave off this. By the way, we always like to point out, I go back and digress a little bit. 6 over 6, 4 over 4, 3 over 3. Those are just ways of naming 1. So in other words, we're renaming the fractions, but their value stays the same. 1/2 has the same value as 6/12, all right? That's why we can interchange these. At this point, we want to know, how many 12ths do we have left? How many 12ths do we have left? So we don't add 12, 12, and 12 and get 36. No, 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 no. Keep the 12, let it go for the ride. Add the numbers in your numerators. That's the top, right? Numerators, denominators in the bottom, numerators on top. And I'm getting 13, because that's 10 plus 3 more, 13. Comes out to, oh, it's an improper fraction, isn't it? Let's make a mixed number out of it. And we're going to have going in there one time because it's division. Remember, 13 is divided by 12. So 12 goes in there one time. Keep the 12. Denominator stays the same, doesn't move. And bring the 1 left over because that's how much we have left over when we subtract 12 times 1 from 13. You have 1, and that becomes your numerator for the mixed fraction. It's like saying 1 and 1/12, 1 plus 1/12. Same thing, same story. We got a mixed fraction or a mixed number, all right? And that's our start. Now, if we subtract, we also need common denominators also. So there we go. Let's see where we're going to go with our next business here, all right? Let's work a little bit. Now let's go to the subtraction approach, all right? And we're going to go ahead and mix numbers in here because I want you to see you've got 7 and 7/8, and we're going to subtract 5 and 1/8. Now, if that's 7 and 5 were not there, you just simply say, hey, I've got a common denominator. I'm going to say 7 minus 1 gives me 6. Life is good. Now, a lot of times I know students appreciate and they like to see them written vertically. I'm going to do both ways. All right, I'm going to do both ways. I think with subtraction, the vertical approach can be better, can be a better choice at times. Now, in this case, it's not complicated, but in just a minute, you're going to see what I'm talking about as we get to the point we have to do a little regrouping in order to be able to do the subtraction of the fractions. I think it becomes easier to see in a vertical fashion. But, that's my opinion, and other people will say, I like it better horizontally, and that's what they need to learn. And that can be very true. I'm not taking that away from anybody. But I just have my preference on this one. So anyway, let's go ahead and look at it. We can subtract because we got common denominators. We can subtract because 7 minus 1 is doable. All right? Now, if it were 1 minus 7, we couldn't subtract that. We'd have to work a little bit at it, okay? We're going to see those kind of situations on down the show here. Just hang on, all right? Now, no borrowing, just straightforward. So let's do it. That's going to be 7 minus 1 is 6. Remember, the 8 comes down for the ride. So we had 7/8. I took away one of them. We now have 6/8. That has not changed. Now, the 7 minus 5, got it. We're under control on that. That's 2. Now, what did I say? Well, I didn't, did I? I didn't read it out to you. You were reading it for me, though. We got to reduce to lowest terms. And in this situation, the 2 is fine. 2 is fine. But the 6/8, we can do a little number on that. Both of those are even numbers. Divide both numerator and denominator. That's both parts, right? Top and bottom. By 2. They're both even numbers. And that gives us 3/4. Now, we can say, yes, we subtracted. Yes, we reduced to lower terms. And not lower, but lowest. Actually, best we could do. And it checks out nicely. That's our start. That's where we're going today. Mixed numbers. You've got to have a few things kicking. You've got to have common denominators. You've got to have a subtractable situation. And then we'll just work those whole numbers in at the very end. See where we go with them, all right? Sometimes they work just like they see, and sometimes we got to do, as we said, a little regrouping. All right, let's take a look at our next problem here. 6 7/10 minus 4.5. Again, I'm going to bring them over here and work in a vertical fashion. And I'll come back and do the horizontals just for you guys who are purists and like that. And I do. I hope we can look at those and start getting a horizontal feel also. Now, in this case, what's going on? Oh, Ernie, we don't have a common denominator. Well, we have a common denominator. We just don't see it yet, or we haven't figured it out. Well, let's ask ourselves. We got 10 and we got 2. We need to have the same number in both of these denominators. That's why we call it a common denominator. We've got a 10. I've got a 2. Will it work? Will 10 be our answer? We hope so. Let's check it out and see. To that question about do we have a common denominator and what is it? So 2 divides into 10 evenly, which tells me that 10 is where we want to go. So I'm just going to put a little equals out here. We're just going to work again. I'm going to keep the 6. I'm going to keep 7/10 because tenths are going to be where we're looking. However, I've got a little bit of work to do with this little guy. All right, I've got a little bit of work to do with that one. How many tenths is 1/2 going to be worth? We're taking care of business here, right? Well, I look at it, 2 divides into 10, goes 5 times. So that's what I've got to multiply this 1 by here. And that's going to give me 1 times 5, which is 5. So we're ready to subtract because guess what? Yeah, numerators are good. I can subtract 7 minus 5. That's legal. That's good, all right? I can also do 6 minus 4. So all is well, all is well. So let's see, that's going to give me 2 and 2/10. See where I got 2 both times? 7 minus 5 gives me the 2, and as does 6 minus 4 gives me the big 2. And here we did, we subtracted. Now we got to reduce. Reduce the final answer. Lowest terms, all right? And that's going to be, hey, 2 over 10. 2/10 comes out to be 1/5, because we can divide both those numbers by, you got it, 2. A lot of 2's running loose in this problem, weren't there? But there you have it, final answer, 2 and 1/5. And I think it's kind of cool. I'm going to mention something here right now. We started with tenths and halves, and we ended up at fifths. That's the beauty of fractions. You can maneuver things around. Equivalent fractions are wonderful to work with, all right? And in this case, once we got that half into tenths and we subtracted, we were back to fifths. Very cool, very cool. And always, that's the importance of being sure you reduce to the lowest terms at the very end. So, starting off some good problems there, hopefully catching on with it. Let's take a look at what happens when we basically subtract some rational numbers. You say, what do you mean by rational numbers? In other words, sometimes we forget to put the fraction on with the whole number, all right? Well, we don't forget. That's just the way the problem was set up. So let's take a look at this. And this is where I like to look at things again in the vertical fashion. And we're going to say 5 and 6/7, and I'm going to put minus 4 right there. And again, this is one of those, yes, you can work it horizontally. You can see that you're going to say 5 minus 4, and it gives you 1. You got 6/7. What do you do with it? Well, when you write it vertically, I think it's real obvious what's going to happen. It's going straight down. It's going straight down here, all right? And actually, I need a little bit of more bottom down there, guys. If y'all can take care of me there, thank you. And I got 5 minus 4, which I can do also, gives me 1. 1 and 6/7. That was really easy, because basically what's going on here, it's like having 0/7 right in there, all right? That's like having 4 and nothing, but nothing can be written as 0 over whatever that denominator is. So I use that as an example because I can do 6 minus 0. I can do 6 minus 0, and here I go. I get a 1 because nothing happening there. 5 minus 4, real easy, 1 and 6/7, all right? And again, as I told you, you could look at that, write it horizontally, and get 1 and 6/7. Just bring the 6/7 over for a ride. I still think it's easier a lot of times to see that vertical fashion. Now, this next part here, we're going to draw a line right down the middle here. This next one, when I put 5 minus 4 and 6/7 here, that's a different story. Now notice I just switched the 6/7 around here, okay? Here, I am saying 5 and 0/7. And you know, I have many students when I've taught in a pre-algebra class and things of that nature, they just bring that 6/7 down there and make 1 and 6/7. Well, it's not the same. First of all, you're only starting out with 5 and you took almost 5 away. So that, you know, that is what we've got to be careful with. So you say, well, Ernie, what are we going to do? What are we going to do? Well, what we're going to do is we're going to take and we're going to have to regroup. I like to say we borrow, okay? We're going to take 1 away from here. We're going to take 1 from 5. We're left with 4. And it's like a little paper shredder, all right? It's going to shred that 4 into 7 pieces, all right? Because, why did I say 7 pieces? Because that's what's in my denominator. That's my LCD. My least common denominator here is 7. So I'm going to shred it into 7 pieces, and I'm going to add that 7 to the 0, all right? It's kind of like a paper shredder. So what does that say? That gives us 4 and 7/7, or 7/7. This one still has 4 and 6/7. And folks, we're going to subtract, all right? And guess what? We aren't going to come up with 1 and 6/7, are we? 7 minus 6 gives us 1. Put the 7 for the ride. 4 minus 4, it's gone. There's my final answer. So yes, these are 2 distinctly different problems, all right? And you work them basically the same way. Fill in where you have a blank space, just put a 0 in there and put it over whatever the other denominator is in that situation. You will be fine. We're going to practice this a little bit, all right? We're going to practice some. Because sometimes that's not just the easiest thing to get right off the bat with just one example. Some of you go like, oh yeah, I remember. Let's see how well you remember. Let's remember and do it right, okay? So we got 6. I'm going to do a vertical fashion here, minus 4 and 3/8. Aha! This is one where I've got 0 over 8 up here. Remember? Just match the numerator. Can't do it, can we? We cannot subtract 3 from 0. Now, if the 0 and the 3 were interchanged, but that's not the problem. It's not what we've got, right? So here's where we're going to go. We're going to do that little shredding moment, all right? We're going to pick up 1 from here. That's going to leave us with 5. And we're going to shred it into how many pieces? 1, 2, 3, 4, 5, 6, 7, 8. Count them, 8 pieces. So we're going to add 8 right up here. And you know what? It's sweet, isn't it? Because that gives us 5 and 8/8. And we're going to subtract. This one is going to give us 4 and 3/8. Can we subtract it? Of course we can. We can subtract 8 minus 3, gives us 5. And we can do 5 minus 4, which gives us, count it, 1, 1 and 5/8. 1 and 5/8 there. Think about it. Let's think about it. Let's pretend that was 4 and a half. 4 and a half. $6 minus $4.50. You sure aren't going to give me back $2.50 change. Well, if you are, you're going to be a good friend, okay? Because you're going to help. You're going to give me a little extra money. You give me $1.50 back. If you had $6 and you subtract $4.50, you've got $1.50 coming back to me. Think about it. If that's not registering with you, count the money out. Put some quarters and some dollar bills down there and check it out, making change. It's a kind of a nice skill to have, be able to do, so you don't shortchange yourself. Now, this one over here, how about it? We got 7 minus 2 and 7/12. Again, I'm going to use this approach. Remember, it's just like having 0/12 right in there, because we have 7 and a little bit of nothing, all right? Absolutely nothing. And that's nothing out of 12, all right? 0 divided by 12 simply gives us 0. So we can do that. We cannot subtract, however, 7 from 0, but we certainly can go over here and borrow 1 from the 7. We'll regroup, play the shredder. This time the shredder is going into 12 pieces. Whoa! So we're going to add 12, and that's going to give us, guess what? 0 plus that's going to give us 6 and 12/12. Easy, isn't it? Over here we're going to subtract 2 and 7/12, and life will be good because now we can do something, all right? Now notice that 7 became 6 and 12/12. That's just like saying 6 plus 1. It's like saying 6 plus 1, all right? That's just what we're saying here, 6 and 1. Although we just kind of disguised that 1 as 12 over 12 because that's what we need. That's what we need. We can subtract 7 from 12. It's going to give us 5 of those 12ths. And we've got 6 minus 2, which will give us, count it, 4. 4 and 5/12. And again, that's your story. That's your story. So it's called like it is. It's borrowing. It's regrouping. It's thinking. It's dividing a unit into a certain amount of pieces. All right? That's where you're going on these. A bit of practice, and as we always say, be careful because you got to remember about that 0 effect. That 0 effect, especially if it's the first fraction and you're going to try to subtract something from 0, it won't work. You've got to do the borrowing or regrouping moment, all right? And that's the story on those. So let's play a little bit more. Let's say we get some mixed numbers moving into the scene here. How about it where we might need to borrow and regroup? Let's pick this one up. It says 4 and 2/3. We're going to subtract 2 and 7/9. Again, I'm going to go vertical on us here. And first of all, you're going like, Ernie, there's no zeros here. Exactly. But the process is still the same. The process is still the same. We need a common denominator first. Now remember, when we had just one fraction, that gave us a denominator. It was our common denominator, all right, that we had to deal with. This time we got 2 fraction parts to it. So the 4 and the 2, don't worry about them. Sometimes I hear people say, we want to make improper fractions. That gets nasty. It gets nasty, especially if these denominators start getting big. It gets real nasty, and then you got to reduce them down anyway. So let's play the fact we notice that 3 will divide into 9, correct? So I'm going to put a 3 right here. We're going to say 3 times 3, but we're also going to multiply that numerator by 3. Now as for the 9, 7 over 9, we're good. The reason why we're good, because this gives me 9 and that gives me 6. So let's see where this takes us. This takes us to 4 6/9 and 2 7/9. And that, my friends, is good news. We got common denominators, and basically 4 6/9 is larger than 2 7/9. So we can subtract, but the problem is we've got a 6 and a 7 here. We can't, if like some of mine, they say, where there's a will, there's a way. I'm just going to say 7 minus 6. Can't do that. You've got to come back and say 6 minus 7, and that doesn't tally here. Doesn't work. So what we're going to do, we're going to go over here, and we're going to try to make that numerator become bigger than this one. What does it do? How does it work? We take 1 away from the 4. Gives us 3. Y'all with me? And this time we're going to shred that 1 that we took away into, remember what I said, it's about the denominator, not about the numerator, but about the denominator. There's 9 pieces. I'm going to shred that in, and I'm going to add it. I'm going to add it to my 6/9 here. So I'm going to add 9 to that fraction right there. When I borrow 1 here, it's going to slide over here and make that 9. So what have I got? I've got 3 and 15 over 9, which we're going to subtract 2 7/9 from. Looks good to me. I've got 9s, common denominator, check. I've got 15 minus 7. I can do that. Well, you can do that. We can all do that. And I can do 3 minus 2. So it looks good to me. How about it? Goes 1 time. We got 8, and our 9 comes along for the ride. There you go. And by the way, where did I get the 8? 15 minus 7. 15 minus 7. And 3 minus 2, bang, it's a 1, it's a 1, it's a 1. And again, these are easy subtractions. I could put big numbers, little numbers, whatever over here. They're not the problem. The problem is what do we do with our fractions? And the fractions, you guys, you can do them. You can do them, right? It's easy because you're watching T and Learn Mathline. It works well. It does. Let's go to one more here for the road. Let's do one more here for the road. See if we can get this one out. This one, 14 3/4 minus 6 4/5. Are we ready? Set, go. We're going to subtract, and we're going to hopefully reduce our final answer to the lowest terms. Mixed fractions. Don't you love them? They're not hard. They're not hard to do, are they? So I'm going to run vertical on us again. I just like running vertical. Just gives me a little more room, a little more play space. Whew! You say, Ernie, where'd you get 13? I don't know. How about it? Let's make that 14. You know, I was jumping the gun. I was all ready to borrow. We don't know yet if we're going to need to borrow. Let's keep that 14. I do not want to confuse anyone out there. Yikes. All right, but what we do need to do first, we've got to make common denominators happen. All right? So we're going to multiply 4 and 5 because that gives us 20. And I'm going to do 4 times 5 again down here, or 5 times 4, commutative property, we like to call it. And that gives me 20. So don't forget, got to come back up and fix that 3. That's going to be 3 times what? 5. What about down here? Everybody's saying, Ernie, I think we know what we're going to do. We're going to multiply this 5 by 4. Look what we got. We got, like I said, I jumped the gun. Got 15 over 20. Here we've got 6 and 16 over 20. Now, don't make that mistake where you say 4 times 4 gives you 8, because you're probably, some of you are going like that at home. You get, I got 8 there. What happened? We've got to do what? We've got to multiply 4 times 4, not 4 plus 4. So be careful. Like I said, I wanted to jump the gun. We aren't going to jump that gun yet. However, if you'll notice, when we try to subtract here, we do have a problem. We do have a problem. Can't subtract 16 from 15. 15 minus 16 takes me into what, a negative territory, and we're not really trying to go there. We want to just do pure, simple subtraction of fractions here, all right? So, common denominator time. We're going to borrow. That's what I wanted to do a little bit earlier. Now we're going to do it, all right? We're going to pick up that 13, and what are we going to do? We're going to shred it. How many pieces? Whew! 10, 20. We're going to do it with 20. So add the 20 right here. Never mess with that little guy. I was about to put the 20 in the wrong place, wasn't I? And my goodness, what do we get? We get 14 and 35 over 20. I told you it's going to be big numbers. minus 16. And we don't have 14 again. I tell you, I am loving this last problem, aren't I? 13. It's 13 there, all right? And 16 over 20. We're ready to subtract. How about it? Balance back and forth. We can do the subtraction here. It's going to give me 19 over 20. And there we go. How about it? 7 and 19/20. Again, watch those numbers. Sometimes I get a little carried away and get a little excited about them. Put them in the wrong place. 7 and 19/20. Take that one, hopefully, to the bank. Don't try to deposit. That's a bunch of nickels, by the way. 19 out of 20. That's 5 cents each, right? So, thank you for tuning in this afternoon. T and Learn Mathline. We've been working with mixed fractions and all sorts of good things with subtracting them. Hopefully you've picked up a few more skills to get ready for next year. And we love having you tune in. We'll be back again tomorrow. See you then. Right on.